Alright, in this video we're going to talk about rationalizing a monomial denominator. Which again, monomial means there's just one term on the bottom. So we got something like, I don't know, say 3 root 5 over root 7. This one is really not that hard. All you have to remember are two things. One is when you have a fraction, you can multiply the bottom by anything you want, as long as you multiply the top by that same thing. The other thing is, well, what does square root mean? It means if you multiply it by itself, you should just get the thing on the bottom. So that's what we're going to do. If we multiply the bottom by another square root of 7, which we can do as long as we multiply the top by square root of 7 also, then on bottom, root 7 times root 7 is just 7. On top, I've got the 3 still, and then 5 times root 7 is root 35. Alright, let's do another one. Let's say, I don't know, 5 root 14 over 3 root 10. Alright, so same thing. We want to get rid of this root 10, so we can multiply by root 10 and root 10. Actually, since these are both square rooted, we could reduce the 14 and 10, make it 7 over 5, but let's not worry about that for now. Let's just keep going. So on top we got 5 times root 140. On bottom we've got the 3, and then root 10 times root 10 is 10. So first thing, this fraction reduces because I have 5 on top and 5 goes into 10. So I've got root 140 over 6. And now the only thing left is to ask myself, does this root 140 simplify? Remember, a square root simplifies if there's a square that divides into it. So the squares are like 4, 9, 16, 25, those guys. Let's just try dividing this by 4. Sure enough, this is 4 times 35. I can pull the 4 outside if I square root it, so that'll be 2. And then the 35 I'm not doing anything to, just leave it inside, over 6. And again, I can reduce the 2 and the 6, make that a 3. So I've got root 35 over 3. Let's do a couple more and we'll call it good. Let's say, I'm just completely making these up in case you couldn't tell. So let's go 14 root 35 over 5 root 6. Alright. Multiplied by root 6 over root 6. So we've got 14 root 35 times root 6 is that's 180, 210 over 5 times 6. The 14 and the 6 simplify because 2 goes into both of them, so that would be 7 and 3. So I've got 7 root 210 over 15. And the only question is, does any square go into 210? 4 doesn't go, 9 doesn't go, 25 doesn't go, 49 doesn't go. So I'm starting to doubt that any of them are going to go. So let's just call that good. And let's do one more. Let's put an x in this one. Let's go 3x root 10 xy over 5 root 6z. Okay. So the variables don't make any difference. We just do the same thing. So I want a 6z to get rid of that 6z. So on top, now I've got 3x root 10 times 6 is 60 x, y, z. On bottom, I've got 5 times 6z. Again, I can simplify the 3 and the 6, make it 2. The 60 is 4 times 15, so I can pull the 4 out and square root it. So I've got 2x root 15 xyz over 5 times 2z, and the 2's cancel. So we just have x root 15 xyz over 5z. So it's all pretty simple. I mean, if you have a square root, all you do is just multiply the top and bottom by that same square root, and then simplify all your radicals, reduce your fractions. That's all there is to it.